So welcome all students, faculty. Thanks, Professor Vindhya, for that introduction. It's our pleasure to interact with the DSE students here. I'm Vivek Singhal and co-founder and chief data scientist with CellStrat AI Lab. We are a US-based startup, but with the team here in Bangalore and rest of India. So we are a community-driven startup, and we are working for a lot of US clients now, developing a lot of AI projects, particularly generative AI, innovations. Generative AI has broken out like crazy. It's like the whole world is like can't get enough of it. You can't open any media nowadays without hearing lots of articles about this. There is Chat GPT, LLMs, or GPT versions, Alpaca, Llama, and lots of other topics. Stable diffusion, image generator. So in our note for this hack day on Tuesday, we have mentioned the topics which are involved. So I hope some of you have sort of started developing your project because I mean there's no limitation that you have to start the set day on Tuesday morning at 7 a.m. and the session is 7 a.m. to 7 p.m. Tuesday. But if you have your team set up, you can start the project or coding work beforehand. Some of you may have already started. Yeah, this is incredible, a breakthrough actually what's going on globally. And it is indeed a pleasure to be a part of this kind of, ecosystem. And the applications we are beginning to see are simply mind-boggling. And we have understood that with this kind of changing AI environment, we have to be very agile and sort of do stuff, in like in a hacking way. We can't do long product development cycles anymore. By the time we plan certain product, things are already completely changed. These OpenAI, Microsoft, Google are launching algorithms at a breakneck pace. So we all have to become very good sort of coders, hackers, and churn out and understand these kind of overnight, literally, and churn out products, at that pace as well. So that's where we are. The pace is so intense. It's extremely exhilarating and extremely lucrative as well, those who can master these kind of technologies. But tomorrow we'll discuss more about generative AI. But to launch, any of these products, we have to have a full deployment kind of knowledge, which generally is something which students, they don't do. They do projects, but how to deploy full stack products, we wanted an overview. So we have a CellStrat team lead, Bhavesh Laddagiri here, who will take a session on full stack AI deployment. And in between, he may also discuss some of the generative AI concepts as needed. So Bhavesh, are you ready?
Yeah. Yeah, I'm ready.
So just go ahead and share your screen. We are recording this session. And students, so pretty much you should start your hack day project like today if you have not started, and benefit from these two sessions today and tomorrow. So Bhavesh, over to you.
Yeah. So, hi everyone. Good evening. My name is Bhavesh, and I'll be taking you through your through you. I'll be taking you through deploying a model on CellStrat Hub. So, yeah, let's get started. Basically, so the agenda for today is basically pretty straightforward. We'll understand what is CellStrat Hub API. We'll get a background on what API itself is, and we'll be particularly deploying a model called Clip, which is a image and text model. So that way you understand both how to deploy an NLP model as well as a vision model. And then we will build the model, inference scripting, everything, and we'll deploy the model. And we'll also create a simple UI for it. So yeah, let's get started here, I guess. So CellStrat Hub in general is basically a development and deployment platform. Where you will get access to a cloud virtual machine, and you can use Jupyter Lab in it to develop your models, train them, or etc. And then to deploy it, we have the CellStrat Hub API service, which where you can basically deploy your models in a very straightforward and simple way, in like under 15 minutes or so. Um, the main thing is that you don't really need to follow any strict format requirements while deploying. There's just a tiny bit of format requirements, but mostly you have like full flexibility and customization available to you. And all your models are deployed as serverless APIs, which basically means that you don't need to manage your server or anything. You just need to work on your code and project. We'll handle the servers and everything, and you only pay for the number of invocations. So you don't pay for idle time. Normally, if you would like, let's say, go to Heroku or something, you also have to pay for the server's idle time, right? Given that Heroku is not even free right now, so like you have to pay even when there are no requests coming to your backend, right? But here with serverless APIs, that's not the case. You only pay for uh, the requests that actually come to you. So yeah, in general though, there's a free tier in CellStrat Hub, so most and you get like 5,000 API calls per month. I think 1,000 API calls or something, or 5,000 something around those free. So you don't technically need to worry about the payment or anything. It's pretty much free for you guys. And also APIs are all auto scaled according to the traffic. So again, you don't need to worry about infrastructure or scaling and everything. And everything that you deploy here is basically a Docker container. If you don't know what that means, that's fine. You don't really need to know about that. But if you do know what a Docker container is, it's basically like a package which contains all the libraries, dependencies, OS, and everything. And it basically, if you know Docker stuff, also you can further customize your deployment and speed up your or optimize your models or whatever. So, but you don't really need to know what about because that's all under the hood and abstracted away. Yeah, so you can deploy in the free tier. You can deploy about 5 APIs for free, and you have like 1,000 API calls per month. So yeah, but for the hackathon, I don't think there's any restriction on that particularly. And 1,000 API calls is already pretty much more than enough. So if you have any questions, you can ask in between as well. So.
To augment that, we will upgrade whoever's needs an upgraded account in CellStrat Hub for the hack day purpose. So that's not a problem. If you want the GPU tier gamma, that's available, or the higher level CPU tier, if you were to check the CellStrat Hub. And by the way, I want to clarify, it is not mandatory to do the hack day project on CellStrat Hub. It is just something we recommend or prefer because that's our company's platform and we understand it. It's really easy to use. If you were to use AWS, Google Cloud, Azure, Heroku, or Flask, whatever else you like to use to deploy full stack AI solutions on the cloud, by all means. But yes, from our side, we can provide good support for CellStrat Hub deployment architecture, and hence we recommend it. But it's not a mandate for your hack day project to be on CellStrat Hub. Okay, yeah, back to you, Bhavesh.
Yeah, cool. Okay. So firstly, we'll first talk about what a REST API is. So a REST API is basically a simple client and server model where a client will make a request to an API, and the API will take that request, send it to the server, and get a response from the server and send it back to the client. As simple as that. So it's a simple handshake protocol sort of thing. You give, you get, or you something like that. So it's a simple gateway between a client and a server to exchange messages and everything. And most stuff on the internet is REST APIs only, like everything. Like mostly when you go to a website, it's a REST API. If you make some request, let's say you're uploading some file to Google Drive, that's a REST API call, and so on and forth. So most of your API calls are all RESTful in nature. So in general, how our API is accessed on CellStrat Hub is that we have like a base URL. So let's assume that this is our base URL, and based on your username and the name of your model that you deployed, you can basically have like your own custom URL, similar to how in GitHub, let's say, it's basically github.com/ your username / your repository name, right? So something like that. So on CellStrat Hub also, you'll have like your username / model name sort of architecture there. So yeah, also let's keep it interactive. I guess you guys can unmute yourself and ask questions, and if you want to uh, yeah make a comment or some question or something you want to discuss, feel free to uh, talk. So yeah. So in a HTTP request, so REST requests are also called basically a HTTP request. You have a few things that we need to know about. So one is the method, which we'll talk about in a bit. There is the location, like where exactly are you sending your request to? And then there are some headers, which are like meta information about your request. So something like what kind of data is it? What format your data do you expect to accept in response? And some authorization information like your API key or something, which will basically authorize who are you. And then our actual content or the actual message that we want to send to the API is basically in the body part of it. So yeah, so the first requests that we need to like learn at least or like just have a basic understanding is the GET request. GET request is a okay. Actually, before I go on that, can anyone explain what a GET request is if you already know or are familiar with APIs? You can raise your hand as well if you want. Or if you don't know what that is, you can also react. There's a send a reaction as well. So
Students, let's make the session interactive. You can unmute yourself and answer.
The web developers are very much used to these kind of full stack web development. So those who are already doing some level of web development or have done some projects would be familiar with the REST API, GET and POST API protocols, right? So client server architecture. So do ask questions, don't shy, because we are really, really challenging you to come up with some interesting products by end of Tuesday, right? So we are kind of challenging you. That is the goal. And yeah, this is a very aggressive actually desire to be able to launch full stack generative AI products in next 2 days. So we have to be very, very agile and be willing to quickly learn and deploy products. So, ask questions, fight, argue, whatever it takes, but we need to see the outcomes Tuesday evening. That is the goal.
yeah. Okay. So a GET request is basically a one-way request sort of thing where you don't send anything. The client, you are not sending anything to the server, but you're just pinging the server, and the server will respond to you with some information. So it's like you just say you're not sending any input information, but you're just asking for some information based on something. Like it could be based on the location or something like that. But basically, the it's usually used for pinging stuff or retrieving information from the server without having to explicitly give out any information as input. So that's the GET request. The next request is the POST request. In the POST request is the usual request that we will follow here, is that you send some data and you get back some data. So it's basically like the client will send like, hey there or something like that to the API, and the server will respond to that message with something, will process it or whatever, and then respond to the client with that information. So that's a POST request. So that's a GET and POST request. Yeah. So okay, let's move on to how CellStrat Hub API basically works. So a client will basically send a POST request to the API with some input. So like it could be a text input, it could be an image or whatever. And yeah, and that is sent to the CellStrat Hub inference API. So your model that you work on will be deployed to that CellStrat Hub inference API, and it will basically perform your predictions and inference or process your data basically. And once that is done, your predictions will be returned to the client as a response to the post request. Yeah, so this is basically how it's pretty straightforward, like the way the workflow work goes. Yeah, so the overall architecture can be like summarized here. Like you can actually you can ignore the first one, but will basically send a input with some request. You'll send a request with some input, and then you'll get some response with the predictions of the model. It's as simple as that. If you have any questions on how an API works, or even what this is, or why are we talking about this, feel free to ask. Otherwise, we'll move on to the next one. Okay. I'm assuming no questions. That means guys understood everything. So let's move on to building the model. So today we'll be deploying a model called CLIP, which basically stands for Contrastive Language Image Pre-training. So you don't need to understand fully like what CLIP model is or anything, because this is just for demonstration purposes. Our focus for today's workshop is how to deploy a model. It's not about what model we are deploying, but it's just how to deploy a model, given that we already have built the model and everything. So, but just to get some background on what we are actually deploying, here's a basic explanation on that. So it's basically like it's a model which has two inputs. One is a text and one is an image. So the way it was trained is that if you input some image and input some text, what it will do is it will give you a similarity score between the two. So essentially it's like a similarity classifier sort of thing. You between the image and the text. So basically, if you have an image of a dog and then you have a text which says that this is an image of a dog, the similarity will be higher than for a text which says this is an image of an airplane, because airplane and dogs are not similar in any way, right? So it's basically a model which can basically unify your text and images into a single vector space, if you know what vectors are. But basically, it's basically a model which will tell you how similar a particular text caption is for an image. So it's basically similarity model. And what we can do with this model is we can actually make use of the similarity feature of this model, and we can create what is known as a zero-shot image classifier. So what does zero-shot image classifier mean is, first we have to understand what an image classifier is. Can anyone say what's an image classifier? Pretty easy question, I guess. What is an image classifier is the question. Do you want me to like take names and ask? Rakshit, are you here? Rakshit, Ankur, Anusha, are you guys here? Okay. So an image classifier is basically a model which will basically classify whether an image, given a set of classes, it will classify an image into, let's say we have a image classifier for cats versus dogs. It can be classified into, let's say we have an image of a dog, it will classify it as either cat or a dog, right? So traditionally, when we talk about image classifiers, your output classes are always fixed. Like you can only make prediction. Let's say you have a cat versus dog classifier and you give the input of a car, image of a car as input. The model will still try to make a prediction between a cat and a dog. It will not, because it's limited to only those two classes. It's a fixed set of classes that the model is trained on. So even if you send any random image, it will still try to give you an answer between a cat and a dog. So, but that's not how the real world works, right? In real world, you can get any kind of image, and yeah, and it's also like if you want to add a class, let's say I want to add cats, dogs, and I also want to add a car, it will be difficult for me. I'll have to retrain the entire pipeline, retrain the entire model, get a new data set and all that. So what does zero shot mean is that you don't do any of those. You don't train a model, you don't have a fixed set of classes or anything. You define your classes at runtime dynamically. So you say that classify this particular image between plane, car, dog, and bird. And what this model will do is it will check the similarity between all of the n classes. Let's say you have 5 classes defined. It will check the similarity of the image with all the 5 classes, and whichever is the most similar class is your answer that it's a dog or whatever. So that basically is zero shot image classification. So this is really powerful because you don't need to train a custom model every time. You can use an existing model and classify it into any number of objects without having to gather data set or train it or anything. So that's why it's called zero shot. Zero shot means you're directly making a prediction on a task that it was not trained for explicitly. So there's also few shot where you give some examples and then you make a prediction. But zero shot means you're not giving any sample examples or any explanation, directly making a prediction without any prior training. So that's the clip model. So what we are essentially building is a zero shot image classifier, which can classify an image into any user defined set of classes. So we don't have a fixed set. It's like defined by the user at runtime. So we don't need to do any training or anything. It's a pre-trained model that we'll directly use. So yeah, so the first thing is before we start the deployment is for you guys to open up the start your workspaces. So I want you guys to just go to cellstartup.com and log into your accounts. So let me just share that part. So when you go to cellstartup.com, it would look something like this. And you can click on sign in and this will take you to the login page. Okay, let me just log out just so you can see. So it will take you to your login page and then you can click on sign in to login.
So those who just requested the access, so I am parallelly creating your account. You'll get an email with your password.
And once you log in, just let me know, I guess, if you are able to log in. And I'll also, yeah. So once you log in, you just have to click on start workspace. So, okay, before that, I'll just give you a quick tour of the dashboard here. So the development area or the development Jupyter lab where you work on is called the workspace. And you will see your current usage here, your when it renews, your storage, the billing cycle, etc. Also see your machine specification. So this is a CPU only machine. So there's no GPU in this particular tier right now. You can upgrade to GPU if you need in further hackathon and all. So I think that works are already mentioned. You can and there are some expansion packs also, which are a bunch of pre-defined, pre-made set of projects that you can use to learn about machine learning or anything. So like a jumpstart project, which gives you like template code for you to begin with. So yeah, and these are some helpful resources, I guess. So one thing that we need to do right now is basically just start the workspace. So just click on start workspace and wait for it to get started. So this can take about 2 minutes or something to boot up. So yeah, so we'll just wait for, also this is a hands-on workshop, so it's expected that you are also doing these things side by side.
So some of you have raised sign up request, but the account already exists. So I suggest if you raised a sign up request before, the account would have been created. If you didn't get the password, just do password reset. It will email you the new password again. Okay, so just try to do a password reset, because I'm trying to create some of your accounts and it's saying account already exists. So just do a password reset in some cases.
You would have gotten a password. Originally, you would have received an email with your password and all. If you haven't received that email or if you missed that email, you can click on forget password and reset your account. So while that starts up, we'll talk a bit about the deployment procedure. So what we'll be doing is we'll be basically deploying a model, right? So as you know, we are going to deploy our model. We are going to create the API to deploy it. So we have to decide on a format that we want to exchange the information, right? So we will like this is all up to us, like how we want to accept the input and how we want to respond with the output. So it could be anything. So for the clip model, because it's a zero-shot model, you have to provide the user-defined classes at runtime as well as the image. So our input will basically be our input. Okay, our input will basically be a dictionary with two keys, image and classes. Image will be your base 64 encoded image. So I'll talk about that, but basically what this means is that its image is a file, right? It's a file. If you want to send it through an API, there are multiple ways to do that. And one way is to encode your image byte data. So every file has bytes, right? It's everything is represented as byte data. So you have to turn your byte and encode it into a format which is known as base 64. So we encode it into that base 64, and it's basically a long string, long text string. So we'll just basically, so our input to our API will basically be that base 64 encoded string format. It's a common format also followed in if you're into web development and JavaScript, and with JavaScript and HTML, you would have already used the base 64 string, because in there it's called data URI. Every file is, when you upload a file or something, it gives you a data URI, which is basically the base 64 string. So that will be our image input. The next input will basically be our classes, which will basically be a list of strings with the different classes defined. So in amongst which classes do we want this image to be classified into? So in here, as an example, it's like plain dog and cat. So this is going to be our input. So this is not something that the platform has decided for. This is something that we as a AI developer have decided that I want my inputs to be in this particular format. So the client, or basically the user who is going to make an API call, will basically be expected to send their inputs in this format. So again, this format will vary depending on what your model is. But generally, if you're an NLP model, you can have like text input or something as your key, and then some text data. You can also have a complete text as well. So it's basically anything that is JSON. So your inputs can only be JSON, that is a dictionary format like this. And the same goes with the output. Your output, again, it's up to us how we define. This part is automatically added, this invocation ID and everything. The thing that you decide is the one inside the output key. So we are, as our model, we'll be sending out a list of lists as our output to the API, and this will be packaged automatically behind the scenes. But your output will basically be the first element in your output is basically the predicted class, like with the highest probability. Then dog is like second most, and the cat is like third most or whatever. So this is basically our API specification. So we call this an API specification, like what is the input format, what is the response format. So this is that. So let's move on to the deployment steps. So yeah, I guess for that we'll have to come back to our dash workspace here. So once your workspace starts, it should look something like this. Like you will have a workspace status as running, and you will have like a stop workspace button and also a launch Jupyter Lab. So what you need to do is you need to click on launch Jupyter Lab, and this will open up a new tab with your Jupyter Lab environment. Also, if you are lagging behind, or if you want me to pause a bit, or if you want time to come to this page, just let me know in the chat.
So whatever request I saw, I have created and approved your account, and you should have gotten your password in email. If you still have, then if you haven't received, then please send your email here in chat if you haven't received your password for your CS Hub account. Please send your email in chat here.
Okay, so yeah.
Yeah, we can slow down a bit. So let's see if everybody has caught up, because we want everybody to be hands-on on this.
Yeah, so maybe I'll wait a couple of minutes for you guys to come to this page. Meanwhile, I'll just give you a couple of explanations. So this is your Jupyter Lab environment, and it has a bunch of things. So one is called this launcher. So this launcher is basically activated with this blue button. If you click on this big blue button, you will get a launcher, and you can see I'll get multiple tabs of launchers. So in this launcher, you can open up a few things. You have three options for creating a notebook, a base Python notebook, a notebook with the PyTorch environment, and another with the TensorFlow environment. So everything is based on Anaconda. So you have three different environments to build your model. So if you are building in TensorFlow, you might want to opt for this notebook. If you are building in PyTorch, you might want to opt for this one. And the other thing is important is if you want to just create a Python file, you can do so with this. And if you want to create like a text file or markdown file, you can do with this. And the other important thing that you need that we'll be using in this session a lot is the terminal. So a terminal is our command prompt sort of thing. In Linux, it's called a terminal. In Windows, you might have heard of command prompt or PowerShell, right? So we'll be using the terminal to deploy our model and do a bunch of other things. So meanwhile, I'll also share you the zip file that with the source code for today's project. Link. So I've sent a drive link in the chat. So it's basically a zip file. So you can download that zip file. And yeah. So also the left side here that you see all these files and folders is basically our file manager. And this can be accessed with this file browser button. You have a Git button as well, and you have some other table of contents and a tab management and terminal kernel management buttons as well. The main thing that here that is important right now is the file browser here. So I'll just open up a new folder. So it's a blank folder. I'll just delete this. So yeah, I'll just wait for you guys. So for you, like if you're on a new account, it should look something blank like this, although not in this order particularly, but yeah, blank like this should be. So let me know when you want me to move ahead, or if you have any questions, if you want me to repeat any step so far. Uh, yeah, please let me know.
Please send a yes if you have reached till this point. In chat, you can just say yes.
If your workspace status shows that it's pending or something, put pending in the chat as well.
Has anybody's workspace started successfully?
Yes, sir.
Okay. If anybody has joined later and needs to know what to do to get to this point, let us know as well. If you joined later and you got lost some point. Do you want anything to be repeated from the beginning as to what to do? So for some of you, it is running successfully, which is good. Waiting for all to confirm that you have reached this workspace point.
So what you guys have to do for those which has started is that you have to just take that drive link, download the zip file, and you can upload that zip file using this upload button that you're seeing here, which is upload files, right? So just click on that and you can upload the drive file here. So I uploaded it and you can see it shows a clip classifier.zip file. So once you do that, you can just right click it and click on, there should be extract archive. Yeah, extract archive. So you can right click and extract archive to unzip it. And also you can use this refresh file list to kind of refresh the browser here. And once you do that, you should be able to see a folder called images, a notebook called clip.ipynb, and a file called inference.py. If you have come to this point, just put a yes in the chat if you're able to upload the zip file and unzip it. Just put unzipped in the chat. Yeah, I'll just wait one more minute here. Yeah. Yeah. Anyone else who has unzipped? I see only Averup Rakshat who has unzipped the files and ready. Okay, cool. So yeah, meanwhile, I'll just explain a few things. So the first thing that we just need to do is open this clip.ipynb file. And once you open it, on the top right, you will see a switch kernel option, or you will see Python 3 written, right? So it's basically the kernel or the environment that you want to run in. So we are going to use PyTorch here. So I want you guys to just go here, click on this, and select PyTorch 1.9 here. So I'll repeat it once again. On the top right, you will see Python 3 written, which basically is switch kernel. Click on that, select PyTorch in the drop down, and click on select. And once you do that, it should be in the idle state, like kernel should be ready. You can see if there's no, if there, it's a outlined circle, then it means that your notebook is ready to execute code. When it's filled circle, then it means it's running some code or doing something. So you can run the first two cells meanwhile. So which is basically installing the clip library, which basically contains the clip model that we want to deploy, and loading up PyTorch and clip and a couple of other libraries like below for image processing. So first, we'll not start with the deployment right away. First, we'll like understand how to load the model, what the model, how we are making inference using the pre-trained model and all. We'll just do that first. So yeah. So also another tip, when it says star here, that means the cell is running. So yeah. So once that cell is run, the next thing that we need to do is actually download the another model as well. So what I want you to do is just copy this code and open up a terminal. So, or you can actually just put it here itself. So just add a cell here. You can add a cell by clicking on this plus sign here. So it says insert cell, right? So just select this insert cell below and put W this command and prefix it with the exclamation point to download the model. And it will basically download a model file here, and you can see it here, right? So if you refresh your browser here, you can click use, like not the entire browser, I'm talking about the file thing. If you refresh the file manager, you can see VIT B32.pt file here, which is basically our model file. So yeah, so if you are able to get to this point of downloading the model, just put model downloaded in the chat. Okay, cool, good to know. A couple of people's models have downloaded. So I'll just repeat it for those who are still running it. Open up this clip notebook, and on the top right, you will see Python 3 written or something written. So just click on that. If it's not PyTorch already written here, just click on that and select PyTorch from the drop down and click on select. Then run the first cell. You can run the cell using this play button, or you can just do shift plus enter. So shift plus enter, shift plus enter. Run the first two cells, and you just copy this command, add a new cell below, put an exclamation mark and paste that command, and again run that cell as well to download the model. Basically, you can do this in the terminal as well, but just to make things easy for now, we'll just put it here directly in the cell as well. So in notebooks, you can use exclamation mark to run terminal commands. I think if you have used Colab or anything, you might know about this already. So just download this file. And once that's downloaded, you can run the other cells, like you can run the next cell, which will basically load the model on CPU. And then there is a so our model will basically be loaded with this clip.load function, which will give us the model and some transformations, which for pre-processing the image. So we'll create a function called preprocess, which will take in the image and the classes. It will pre-process the image with this transformations object, and it will use the tokenize function to tokenize it. You don't really need to know everything here right now because we're not focusing too much on the model. But just run these cells. So run this cell, then run the load sample data cell. So what this will do is will go to the images folder, and we have a bunch of images here, right? So we'll just load up some sample images here, and we'll also create some sample set of classes. So like kids playing, dancing, Elon Musk wearing a face mask, aeroplane, traffic, or whatever. Just create that, and then we have a predict function here, which will basically put everything together in one single function. So pre-processing the image, forward making actual predictions, turning into probabilities using softmax, and just sorting and formatting the final output in a presentable way. So we'll just do that and then run this. So run all the cells before this deployment part. So just run this part here, and you should be able to see the predictions being printed out as outputs. So you can see your predictions for Elon Musk.jpg is the first prediction is like with 100% accuracy is this caption. A photo of kids playing is again 99% for this image. For the Minecraft image, we have a photo of kids playing, which is, yeah, because we don't have a Minecraft class, right? So that makes sense. And again, for paragliding, we don't have any class defined, so it will still try to make some prediction amongst the available classes. So you can add extra classes if you want. So let's say we add Minecraft and paragliding as well as classes, and then we should get better output. So you can see the Minecraft image now has Minecraft and paragliding as paragliding. So aeroplane and traffic. So we just so yeah. So as you saw that we are able to dynamically define a set of our own classes that we want the image to classify in from amongst, right? So so this is the idea behind zero shot image classification. Is that you don't need to really train a model, custom model for any new class. So I just added two extra classes here, and it was able to predict it right correctly. So that's it. So if you are able to run till development part, so this development section, so all this development section, if you are able to run this, put development in the chat or devs in the chat maybe. So while we wait, I'll also explain what this other file is. So this was in the notebook. Right now we want to deploy it. We need to create like a Python file for it, for our model and everything. So here's a simple file called inference.py. So we just open that up. It basically contains a class which will basically load up the model, and it will have a pre-process function, and it has a forward function, and has a post-process function, and which is basically to format the outputs into a proper sorted format with the first item in the list being the correct class. So that part and the predict part as well. So the bed will basically run everything in a single pipeline. So this all of the code that we just ran, uh, and you're able to get these outputs, right? So it is all just wrapped up into a clip image classifier class. You can go through it if you want. It's pretty straightforward. You have the normal init function with our models being loaded and a tokenizer. We have a pre-process function, which will basically do what this pre-process function already did here, right? So it's basically that. The forward function is basically the first two lines of the predict function, like the this part and this part. And the post process is basically this other part, which is basically doing the output formatting. So if you remember, our output is supposed to be in the format of with the like in this sort of format with a list of tuples, which the first element being the class name and the associated probability with it, and it's all sorted according to this probability. The first element is always the top element, the top prediction. So it's sorted output. So that's why we're using sorted function here, and also in the post process here. And the predictor is basically combining all the other above functions into one single thing. So cell.preprocess, pre-process, cell.forward, cell.post process, etc. So yeah. So yeah, so once we do that, we can now test the script. So we'll just run the same code again, but in the form of that class to just make sure like we're getting the same outputs as before. So you can run this deployments as test inference script part as well. So these three cells, and you'll get the same output. So yeah, so this is basically it. We basically just tested our model code. We didn't deploy anything. We didn't do anything right now. We're just testing our model, whether it works or not. And we just packaged it into the proper Python file, because when we deploy it, it's going to be deployed as a Python file only. So the actual stuff of deployment will just start now. So, but before that, let me know in the chat if you're ready for deployment. if you have done everything up till now, if you are able to follow and run all the cells till the test inference script part of the deployment section, if you're able to do that, just put ready in the chat or done in the chat.
So friends, this is like a crash course in deploying AI models on CellStrat Hub Cloud. That's what this session is. Do rest of the people need some time to catch up? Or you want Bhavesh to go back and repeat certain steps? Only 2-3 people are kind of keeping pace, but what about others? So if you want certain parts repeated, don't hesitate to ask.
Yeah. So the next step is basically to start the actual deployment process. So deployment, so I'll just share a few things. Yeah. So we'll just get a basic understanding of how deployment works. So our deployment is basically divided into like three main steps, or like if you want to include everything, like 5 steps if we totally count everything. So the first step is we initialize the project. So are there any web developers here? Have you done any web development, or if anyone has done like React projects, particularly React or Angular or Vue.js or something, or Next.js or whatever? If not, that's fine. So basically, what the first step of initialization is that it basically generates some boilerplate code and template for your project, for the deployment project, for a model that you're going about to deploy. It will create a bunch of already boilerplate code and template, which will have something already ready to go. You just so that is the initialization step. The next step is actually to add your own code and the source code with your. So in our case, we had our inference.py file, right? So we'll add that code as well, and we'll basically call that function from our main.py file, which is basically already again a boilerplate, which is already there. We'll add some libraries, like what libraries do we need require to run this thing. So in our case, it's the clip library and PyTorch library. So these are the two main libraries that we need to run. So we'll do that. And once we add our own code, so in this integrate step is the manual part. So everything else is automated, but the integrate step, this like it is something that you have to do as a developer. So once you integrate those things, we'll be building the API, which is basically like a package development sort of thing. So it will install all the libraries and create like a ready to go package sort of thing. Technically, if we talk about it, it's basically building the Docker container. But if you don't know what Docker container, that's totally fine. Building step is basically to just create like a ready to go package of your model. So once that is done, we can locally test the API before deploying it, because there could be issues in our model code, right? So when we integrated it, we might have made some mistakes. There could be some bugs in our code or everything. So before finally deploying it, we'll just test it out a bit locally inside the notebook itself, in our workspace itself. And once it passes all our tests, we are able to like use it and everything. We'll then go on to deploy the API to the world, and then with the API key, you will be able to test your models basically.
Bhavesh, are docs up? The docs website is up.
I don't think so. Maybe not. Not right. Yeah, it's not.
So is it possible to share this PPT with the audience here?
Yeah, this is
Because
again.
yeah, good written instructions will help.
Yeah, these instructions are also in the notebook actually. So it's
Okay.
yeah, let me share the notebook right now. Uh, so the notebook also contains these steps. So initializing the project, integration, adding the libraries, building, and everything. So yeah. So let's start with the first thing. The first thing is we have to open a terminal, right? So let's do that. So I think you're all in your base folder, but I'm in like workshop/dsce folder. So I'll change directory. So you can use the cd command to change directory if you are in a different folder. But if you're in the base folder, that's you don't need to do anything. Let's change in directories, and yeah. And now we can run our first command, which is hub init clip classifier. So I already have deployed clip classifier, so I'll write clip DSCE. think they are. I think that's your short form, right, for a college or whatever. So yeah, I'll. So this is the name of our API basically. So this could be anything you want. It could be your name. It could be anything, but make it descriptive here. If it's better to make it descriptive, so clip model or something. So I'll just call it clip. I'll just call it clip D actually. Okay, let's call it clip. And once you do that, it will basically create a folder called clip.dsc. And if you see on the left, or if you can just click on this refresh button here, you can see that you will have a bunch of files and folders here. So let's look at what all those files and folders actually have. So here we have two folders, a model folder and a source folder. The model folder is basically an empty folder, but this is where the PT file that we downloaded, right? And at the first, which is basically a model weights, that file will go here. And the next folder is a source code folder, which is src. There it already contains three files. The requirements.txt is mostly an empty file. uh, there's a utils.py, which contains a bunch of utilities, actually just one utility, and this will actually be useful for our current project, which is converting base64 to an image, because our API, as you remember, will the client will be sending the image as a base64 encoded image, right? So we need to convert it back to a normal image file, or like a NumPy image, or a PIL image. So to do that, we'll be using this utility, and then main.py is the actual file which actually gets executed. So it basically contains like a template sort of thing. So you have like a few things here. So this is the actual function where you will get your inputs from here basically, and yeah, you'll do your prediction code here, something here to basically get the output. So we'll get to how to integrate and everything in a bit. But apart from the source, there's also a hub config.json. You don't need to do anything here though. So it just completes the name of it just contains the name of your project and the version if you are into version control. And then there's the Docker file, which again, you don't need to change anything. So you don't need to touch this anything. So let it be what it is. So no need to change anything or anything. So the Docker file is also there. So these are the main files. So let's start with the integration. So the first thing that we need to do is we need to copy our this file. So do you see this VIT-B32 file, right? So what I'm going to do is I'm just going to cut it. So I'll just cut it and go to clip DSC file, a folder, go to model folder and paste it. That's the first thing I would do. So yeah, I hope I'm not going too fast, but I'll just repeat what I just did. So there was the VIT file here, right? So I just right click it and clicked on cut, and then I went to the project folder and to the model folder, and I pasted it here, like with the normal paste option when you right click it. So that is the first thing that we have to do, is copy the model file to the folder. The next thing is we have to replace, actually, before we replace, we just let's copy our inference.py file as well. So the inference.py file is again, right? So we'll just copy it, go to the project folder, go to source and paste it here. So this time we have to paste this. So any source code that you have, right? Any source code, like be it your model source code, any other files or Python files or anything, all of that goes into the source folder. Only the large model files. So for example, this is like what, 340 MB almost. So 340 MB, it's a relatively larger file, right? And most models usually are in the GBs, like you'll have 1 GB model file or something like that. So although big files, model file or anything else that is big in size, that needs to go in the model folder. And all your Python files and everything, or like text files or JSON files or anything, configuration related files, anything that you may want to use or library or anything, all of those will go in the source folder here. So those things you need to remember. So we just copy pasted our inference.py file in this folder. Now so we'll just, so I hope everyone has done this, has come to this point of copy pasting the model and the source and the inference.py file. If you have, just put yes in the chat. Then we'll move on to what to do with the main.py file. It says that replace the main.py code with this, right? So we'll come to that point. If you have copied the model file, if you have done these first two steps, like if you have completed the first step of copying the model file and also pasting the inference.py file here inside this, put a yes in the chat. Okay, so I guess we have a bunch of yeses. So I'll just discuss a bit on the main.py file. So before we do anything, so I'll explain what is going on here. So there's a function called inference handler. So this is the actual function which gets your where you get your inputs. And here you will add your prediction code to basically manipulate your inputs or whatever. So in our case, our inputs will be basically twofold, right? One, our image will basically be inputs and image, and our classes will be defined as inputs classes, right? If you remember, we had our dictionary, right? That will be our one with being the image and another being the uh, one. It looked something like this, right? Our original format for inputs. So this will be our format, right? So our base64 image will look like this. So image B64, I'll just call it. And our classes will basically be a list. So all this thing will be available in our inputs variable here. So we will do our predictions and everything here with these two inputs, and we'll return the output here. So this is what this inference handler will do. However, this inference handler, but you have to load your model and everything, right? You just put your model in a separate folder called model, right? So what actually happens when you deploy your model is your model is basically deployed into a separate storage server while your inference code is deployed to a separate point. So to connect those two, there is a particular path, like a folder path, which is basically provided to you in this model dir variable. So this thing is like static. You don't delete this. So any files that you have copy pasted in the model folder will be accessible via this thing. So it's basically, if you look here, um, I'm in in the notebook. This is the notebook, by the way. So I actually, let's just copy it here right now only. So I'll just copy all this code from the notebook. So copy this code and just Control A, delete, and then paste it here in the main.py file. So just update your main.py file from the code here, and that is described in the notebook instructions. So yeah, so as you can see, we are loading the clip image classifier and passing in the model. So our original source code will accept a path to our model, right? So model path. So that model path is basically defined like this. So os.path.join model dir plus the name of the file. So this is basically the path to that folder. So if you, many people actually get confused with what this model dir is or how to use it. If you have any questions, feel free to ask me for clarification, like what this model dir is. It's basically the path uh, to your model folder that once you deploy it. So it's like a universal path sort of thing. We don't know that path. That's defined when you deploy it. So that's why we are getting it dynamically like this. So this environment will gives you the path to the directory of your model. You can use this in your code to load model and other large files. So every large file will be accessible in this folder. So this is basically the location of that of your folder which contains this model file or any other files that you might have put into that folder. Did you guys understand what this model dir is? You can, yeah, let me know if you didn't get this part. Okay, I'll just repeat it again nonetheless. So the model there is basically, so we put our model files here, right? So this is a separate location, right? So that location is basically defined, this folder called model. We know that it is currently like one directory up into the model folder, but once you deploy it, it will be like a separate folder. So so that location of that folder is basically described by this model there. So it's saved in the environment variable. So that's why we are doing os.getEnv. It's an environment variable called model diff. So we just get that, and then we can just do os.path.join to basically get any other file paths, particularly inside that from inside that folder. So that is that. So yeah, so we had our inference.py file, right? So we are also loading that inference.py file clip image classifier here and loading our model. So anything that let's say model loading and everything, you have to always do all of that outside this inference handler function, because this inference handler will run every time you receive a request, right? But you don't want to load your model every time you request a request. You just want to load it once and then just use the loaded model for making predictions and everything. And that is the reason. So yeah, so let's talk about the other parts in the code here. So the other part is we are using the utility from our utils as well, the convert base64 to image. So we load our image here and we set the return type to pillow. It is basically the Python image library pill format. So we do that and we get our image, and we also get our input classes, and then we'll use the classifier.predict with our image and input classes to basically get our output. So that is just what we'll do, and then we'll just return that output, as simple as that. So because we already had our code, we just had to integrate our own code here in this part to pre-process it a bit, let's say like converting the base64 image to a normal pill image and making a prediction. Any questions so far? So yeah, so that is the main.py file. So just repeating again, you just have to copy this main.py file code and put it and replace it in this main.py file here, and hope you have already pasted the inference.py file. And the next thing is the requirements.txt file. So which is again empty, but we have to add libraries to it. So we have to add two libraries here, the PyTorch library and the clip library. So we'll just do that here. So I'll just do PyTorch plus CPU. I hope it installs only the CPU version, but let's see. So you can put Torch as well. I'm seeing if I can put Torch plus CPU to install the CPU version only. Yeah. And yeah, once you add those libraries in the requirements.txt, we can actually go ahead and build the model. So to do that, just cd into your project. So in my case, it was clip dsce. So I'll just do that and just run hub build. And what this will do is it will first check if your model, if you actually copied your model files in the directory and if your libraries were installed. And it will upload your model files to our storage servers, and then it will start building the image. So the next command to basically run in the terminal is the hub build command from the folder, from your project folder. So you have to change directly into your project folder to run this command. Otherwise, it will say that it's an invalid project folder. Yeah. Okay. So as you can see, I got an error that invalid requirement torch.cpu. So I'll just remove that. So this torch should be fine. Actually, let me get the particular version here. It's better. Yeah, I'll actually install Torch 1.13.1 plus CPU. So you can just update this if you want, or if it's just Torch, that's also fine. But if you want, you can update this folder here. Yeah, so I'll just run the hub build command again. Okay, I'm still getting an issue here. I'll just, okay, just install Torch. Now let's don't worry about that too much. Just follow the normal Torch and git plus clip command here. Don't add versions. For now, I guess I had the wrong version, so. You can ignore these red markings which says warning. It's fine. You can just ignore that safely for now. So while it is still building, I'll talk a bit of about the local testing. So once it is built now, so you can actually run a development mode of it called hub dev, and you can actually make a request to it. So we'll basically are just loading the images as base64 strings and creating a payload, a dictionary, basically an image of classes, and then we'll just make a post request to it to basically check if we are getting the right result or not. So that is the local development mode. And once that is successful, we will deploy the model with the hub deploy option. And then you will get your deployment endpoint. You will create an API key as well, and then we'll test it. And then there will also be we'll also look at something called MESI sort of thing, which is basically which stands for multi-step synchronous inference, uh, which will basically use to over to for certain situations where your input is greater than 4 MB in size. So that is something we'll test out as well. Because let's say images could be potentially be like in your model, at least if maybe not for this particular model, but maybe for your other models that you might be taking videos as input or audio as an input, which could be greater than 4 MB in size. So you will have to use the messy mode for that. So we'll talk about that. And then finally, we'll also create or at least a simple web application using Python, using Anvil, basically, which is a drag and drop tool sort of thing with with slide code in Python. You can just basically click on this link to clone a project, clone the project already, which is already there. So yeah. Okay, so the building is complete on my end. So the way to test it is we'll start by running in hub dev. So just run hub dev first, and it will say that running development inference server, your local inference endpoint is this. So this inference endpoint is pretty much same every time. So you don't need to worry about that much. So let's come out to our notebook and go to the local test in test the API in dev mode cell. So we'll just run the first cell, the second cell, and the third cell. And this will basically test our so we are actually making a post request now. As you can see, we are sending some data in and we're expecting some response from the server. So this is, you can get any error logs or anything here. So right now everything seems fine. I don't really see any big errors per se. Yeah, I think we get an error here. Let's see what the issue is. Device is always set to CPU. I think the Torch version is 2.0, which is very updated. We'll actually see if I can do 1.13.0 instead. So yeah, so now as you can see, we got an error, right? So let's see what, so this is why we have to first run it in TED dev mode to check for any issues. And the usual issue I think is something to do with CUDA, but even though we don't have a GPU, it's still trying to do something in CUDA. So we have to find something which works with, which doesn't, like which doesn't work with CPU, CUDA and all. So let's see what we can do here. Uh, Let me see if I can. Yeah, so let's try to just specify a version here. So torch is equal to 1.13 and see if it works. So control C to exit the development server and just run hub build again. like recently PyTorch was updated to 2.0, right? So this code was originally designed for 1.13, I think, or 1.13 or 1.9 or something around that. So let's see if we can work around with that. Wait, did you build the model, Shreyash? You said that unable to find it. That means you didn't build the model properly, or when it was building, you might have gotten some other error potentially. So maybe run the build command again. So let's see if we still get the error. Uh, so again, run hub dev and see if it works. Hmm. It is working, but we're getting some other error here. Oh, I think this is yeah, there. Actually, let's also deploy the model because there is probably a bug from AWS side on around this. So this is actually a known bug from AWS. So you'll have to check it. So just run hub deploy as well. If hub dev is not working for you, just ignore it for now. We'll just directly deploy and see. Again, this can take a couple of minutes to run.
How far all students have reached? Anybody up to this point? If you see that notebook, all the instructions are given in that Jupyter notebook. So even if you got lost somewhere, you can read the instructions and pick it up. This notebook is specifically designed to run in CellStrat Hub for AI deployments. If you try to run it in Colab, I suppose it will not do much. But you are welcome to do your Hack Day project in other stacks like Colab or any of the cloud providers and so on. With no code, low code web platforms, you can easily develop a client as well, which calls your AI API on the cloud, such as Anvil.works. Shreyas has some error, Bhavesh.
Okay, could not detect an error. Like one way is to you can run Docker system phone. So just run this command if you want to try to reclaim some space. And if not, there is a potentially like you might have to upgrade to a higher tier to actually do that. Like if this doesn't fix it, let me know. First try this command. Docker system prune. Yeah, on my end it seems to be deployed. So let me just test it first and then we can talk a bit. So yeah, so once it deploys, it will basically give you a URL to your API, which basically contains your username slash your model name at the end. This thing is constant for everyone, so it's just a bunch. It's a confusing string, but it's constant for everyone nonetheless. Just copy that link, paste it here, and we also need a API key. So what you can do is you're currently on this page in your dashboard, right? So there will be a button called deploy model. So just click on that. And in your case, there won't be any API key. So what you can do is you can, so let me, let's say, create API key. You can click on create API key, select your deployed model. So once it deploys, you'll have to do that though. So in my case, it's clip DSC. So I can click on and then click on create. but I already have 3 keys. I think maximum is that's the maximum limit. So yeah, I'll edit an existing key for my case here. And you can click here to reveal API key, copy it to clipboard, then go back here and then paste it here. And let's see if I get the error. Restricting values. Let me see if the payload is in correct format. Image. Maybe I'm trying a different image to see if it works.
Shreyas, what is your space issue solved? Shreyas K.
Yes, sir.
Okay.
Never mind. Okay. Yeah. So the dev mode is working. It's a bit buggy because of AWS from AWS side. But apart from that, the deployed model seems to be working. So yeah, so yeah, so I'm getting the output as dancing, airplane, blah blah blah, all of this. So let me just try it again. Now what happened? Okay, yeah. Just rerun this. Yeah, seems to be working fine. Yeah, so in all our APIs, because these are serverless, right? So there is a concept called cold start. That means when your model is idle or you haven't made a request to it in the beginning only, it will basically be in sleep state or like a cold state. And once you make a request, it will basically spin that instance up and it will take an extra bit of time. So it can take like a minute or 30 seconds to a minute to basically warm up. So that's why the first request took a long time, but the subsequent requests are like within a couple of seconds only. So that is one thing you need to remember. Like your first request will always be longer, like when you make after your deployment, or if your model has been way idle for long, then again it will go to a cold state. So because that is the reason you're able to only pay for the like actual invocations and not the idle time, because during the idle time it goes to a cold state to save resources. So that is the normal thing. So once you deploy it, you can actually paste your endpoint. You can create an API key. So I'll show the API key process again if you want. So to create an API key, what all you have to do is just click on create API key. You have to go to the deploy models part. So go to deploy models, create API key. So once your model is deployed, it will be visible here as whatever your name of your model is. Click on that and click on create API key. And once you do that, you can basically click here to reveal API key and copy that API key to use it. So that's basically your authorization key required to make in any invocations. Yeah. So that is one thing. See. So I'll just, if anyone has been able to deploy it, let me know. Has it did it deploy for you? Okay, so if it's deployed, then put your endpoint, which you might have gotten as your endpoint key here, endpoint URL here, and put your API key and test. Maybe use the zero image or some other random image and try it out. And if you're able to get a successful response like this, let me know. Okay, cool. If it's able to pattern correctly. Okay, so once that is done, I'll explain a bit on the multi-step synchronous inference as well, or MSSI or MESI or whatever you want to call it. So the current limitation in a normal post request, when you normally make a post request, right, you have a limitation that your input size can only be 4 MB. And if you have a model which takes large files, let's say like a video file of, let's say 10 MB, 20 MB, 25 MB, you cannot use this method. You cannot make a direct match. So that is why there is a multi-step process to actually make that request. So your base endpoint, this is constant for everyone. The first thing that you do is you actually make a request to base endpoint slash input with a get request to it particularly, and that will give you a URL, a pre-signed URL and an invocation ID. So we'll talk about what this pre-signed URL is. This pre-signed URL is basically a link where you can upload your inputs. So your payload is here, right? So this JSON payload, you will put that JSON payload to this URL. You'll make a put request. So there are also another type of request called put request. This request is like post request, but it won't give you anything in response. It will just put the you will send some data, and that's it. The server will will give you a confirmation that you have received that the server has received the data, but it won't give anything in response. So there are three. So one, we talked about get is like you don't send anything, you just get something back from the server. You will put something on the server, but you won't get anything response, any response as a reply to your input. But the post request will is the basically a two-way handshake. You send some data, you will get some data back. So yeah, so we are making so the second step is basically making a put request with this JSON payload. And the third step is basically now we'll again make a get request, but this time we'll not send the input data. We'll just make a request to our model, and we'll add another slash and add our invocation ID there. So in practice, it looks something like this. We have our base endpoint here. We paste our API key. So let me paste my API key as well. I'll just copy this and paste it here. We put our headers, normal XAPI key header and whatever. We put our payload, but now what we do is we add base endpoint plus input. Basically, it will give us a which is basically slash input here. It's basically that URL essentially. We do that, and we make a get request, and we'll get a pre-signed URL. So you can see we got an invocation ID and a pre URL where we can upload our data, to which we can upload our data to. So now what we'll do is we'll make a put request and put to our pre-signed URL from our previous response and put our payload here. So this is the actual place where we are sending in our input. And response code 200 means that it was able to successfully upload it. So once that is done, now will actually retrieve our prediction. So this is like a multi-step stages. So you are uploading your data separately and you're getting the prediction separately. That's why it is called multi-step synchronous inference. So what we do is we now make a get request to our username. So my username was gradient fire and my model name was clip dsce. So and the after that we'll suffix it with the invocation ID, and then we will make a get request to it. That's it. And this will actually make the prediction by getting that data, and we'll get our output. So to try this out, you have to put your username and everything and model name correctly here. and put your API key here, and you should be able to run this. So if anyone is able to run the messy format as well and getting the right outputs, let me know in the chat. Or if you have any questions according, it's a bit multi-stage. It can get confusing, but for larger payloads, this is something that you would have to follow. For less than 4 MB files, it's the normal post method is fine. For greater than 4 MB, you will have to follow this sort of method. In fact, just even greater than 264 KB, actually, I would say that follow the messy procedure. Once that is done, that's it. Basically, we'll have our model is deployed. Now we'll just create a simple web app for the front end. You can click on this link actually, but yeah, meanwhile, okay, you're getting the response. Okay, cool. So about others, I think Shayesh was also following along. So Shayesh K, is it working for you? Okay. So yeah, so if you're getting this output even in the messy format as well as the normal format, in most cases, I would recommend you guys use to messy format. It's like error-free mostly. The post request you can still face a bit of an issue sometimes, because you are the client, right? So when you're developing the application, you can just it's a bunch. If your backend is Python, this is the code here you already have. If you're doing web development in like JavaScript or something, you can extrapolate it. You can use maybe to ChatGPT to convert this code to a JavaScript code if you want. Like convert this code, sample code here. You can do that if you want. But yeah, it's pretty. So it's three requests basically: a GET request to get the URL, the upload URL, upload the input to the pre-signed URL or the upload URL, and then make a GET request with your invocation ID as reference to get back the results. So it's a dynamic URL. So that's why like you have your your username, your model name, and a dynamically assigned invocation ID, and then you make a GET request to it. So once you are done with this, we are at oh yes sir, but at last got an internal server error at GET request code snippet. Did the post version work for you? Did the original post version work for you? Shesh, did the original post version work for you, like without the multi-stage process? Okay, that and you got that output, but in the last get procedure, maybe try running the cells again. Just make sure is your username and all this set correctly here, the model name and the username. Is that correctly set? Verify that, and also verify your API key is correctly set. Let me know if it's working or not. Yeah, okay, cool. Yeah, just set your username, it should work. Yeah, so once that is done, what you guys can do is you can click on this clone the project here, right? Anvil. So first I would want you to maybe go and create an account maybe. So go to anvil.works. So I'll just put the link here. Anvil.works and click on start building. I'm already logged in, so I'll just sign out. Just click on start building and you can sign up with a Google account. So I'll just try directly sign in with my Google account. And once you open that up, it should look something like this. So Anvil is is a website where you can build web applications using drag and drop interface for the front end, and for the back end, you can use Python. So everything is Python. So if you don't know web development, JavaScript, HTML or anything, you don't need to worry. You can use Anvil for that. So there's a bunch of documentation as well for this. So there are tutorials and everything you can go through. For now, there's already a clone link in our notebook here, right? So clone the project at the end. So you can actually just click on that. And it should ask you to clone clip image classifier. And you can click on make copy. And once you do that, your interface should look something like this, maybe. Yeah. So yeah, so once it looks something like this, let me know if you're able to get to the screen. So I'll just put it down. So I'll just give you an overview. So on the right, you can add buttons and everything. And you can add a upload button, a make predictions button, and a text box here. So I added that you can add a list of classes separated by comma. And on the front end, if you click on, so this is the design, you can click on code to functionally manage it. So like when you double click the upload thing, you can add code like, okay, it's coming on the right side here.
The Anvil screen is not showing, Bhavesh.
Oh, okay, sorry. Is this fine right now?
Yeah.
Okay. So, okay, let me show this part again. So click on this Anvil link and it will ask you to clone your, it will give you a pop-up saying whether you want to clone this project. So you click on make copy and this page will pop up. So when this page pop-ups, I would advise you to go through the Anvil tutorials generally, but I'll just give you like a brief overview here. So you can add components like titles, buttons, text boxes, and everything, and an upload button as well for files, which is already added here because it's I already created a project here. But you can double click it yeah, to check the code. So this is the front end code, and we are just using base64 library to encode our image as base64 string. Similar to what we did in our notebook as well, there was code, if you noticed, for to encode it into base64. So we did that. And our predict function was basically calling a predict function. So there's also server module here, which is basically our point where we are actually making the request. So we have our base endpoint here, we have our API key here. So I would advise you to change this API key. So this is my API key. So you might want to test on your own model. So replace it with your API key. The headers will be there, and then there's a predict function. So you can directly use this snippet as it is for your project if you are intending to use Anvil as your web application front end. So use this, and although there is a 1 minute timeout on Anvil side for API calls, so uh, yeah, that is something you might want to consider. Even for our models, there's like a 15-minute timeout. So after 15 minutes, your model will time out API, but 15 minutes plenty for a model, so it shouldn't be an issue. Yeah. So our predict function will basically take our image string and our classes, our input endpoint. We upload response, the same thing. We send a put request and everything, and then again change your username and model name here. So it is currently set to mine, but you can change it to yours, and you should return that output. So this is basically like the server code is basically what we had in our notebook essentially, just put in a predict function and add it with a decorator called anvil.server.callable. So we're just calling this function from this form using anvil.server.call. Like I won't go over like yeah, as I said, yeah, I would advise you to watch some Anvil tutorials to understand what is exactly going on here, because this is a separate platform on itself, so we don't have that much time to go over another platform. But everything is already set, so what you can do is you can just click on run, and you can upload a test image. So I uploaded the kids playing image. I can add kids playing, traffic, dogs, cats, etc. as a list of classes. Yeah, maybe Elon Musk as well, because that was one of the images. And then we can click on make predictions. And you can see yeah, so as you can see, we got our output, kids playing, dogs, traffic, etc. The same output. We haven't formatted it, but yeah, you can, once you go through Anvil, you can format it and nicely display it in a good UI. This is just a functional UI right now. So, but yeah, So this is, and you can just stop it. You can also publish your application by clicking on publish, and it will give you a custom URL. You can create a custom URL for it and uh, access it across the internet basically normally. So you can just publish this app and it will give you a random thing. You can change the URL as well to something else if you want to. And it will be accessible on this branch basically, on this URL. So, Shesh, sir, yeah, if you're, can you, okay, so, yeah, so one thing is, this is it actually for this. We deployed a simple UI as well for this. So you can use this UI. You can, in the server module file, you can change your API key and your username and that part here. And if you're able to deploy that, is nice. So if you are able to complete all of this, then good job. You have completed this workshop basically, and you at least got like a basic a high level overview of deploying models. But the actual thing is, I would want you to deploy some of your own models as well to actually get the hang of it. Because currently we just use the pre-made code, right? So once when you actually deploy it, you'll have to write your own code and everything. So yeah. And Shreyash, I think, can you show your notebook? Maybe share your screen or something to with the issue that you're facing. If it's running locally and why it's not running after deployment is a bit weird. Like when the normal post one worked. Just clip. Is your model named? Okay, it's model name clip classifier only. Hmm. Okay, can you use the normal post request again just to see if the normal post request is working? Scroll up, yeah. Just run this cell again. Yeah, this cell. Yeah, maybe run this cell again. Uh, maybe change the image strings to, yeah. Now run it. Okay, that is working. Okay, now run the MS, the cells below again, all these cells again. That's weird. Um, is your username? Can you scroll up a bit? Scroll up. Is your username and everything correct? I'll check in the post URL. In the post URL also your username is there, right? So no, just go back to that notebook only. Show me the post one. Scroll up. Yeah. No. Yeah. Scroll up a bit more. Yeah. Acha, you haven't deployed the model. Yeah. Did you deploy the model? This is the local development mode. So just Control C and exit this. Run hub deploy. Deploy. Yeah, you forgot to deploy the model, I guess. That's why. It should work once you deploy it. You're trying to test it on the local endpoint instead of the deployed version. Yeah. So I think did you delete some cells? I think one cell is deleted for you. Seems like it's deleted. Or you just put it on the wrong side maybe. Yeah, this was the test the deployed API section, right? You are using the local endpoint in that. So yeah. So this will give, once this is deployed, this will give you another different URL. Use that URL in that previous cell and then test it there. Then in the MSSI, I think it will work. I hope you got that. So yeah, I guess that's it actually. Mainly, if anyone has any other questions or anything, they can feel free to ask. A few things I would like to say though, is that deployed models don't have access to the internet. So keep all your downloaded stuff beforehand. So I'll just let me share the slide that I'm referring to. Yeah, like so anything that you want to download, keep it in the model folder. And there's no access to GPUs also by default. So your models will only have access to about 4 to 10 GB of RAM. By default, it's 4 GB of RAM. Your models will have access to CPU RAM, but you can on request you can get up to 10 GB if you want, if your model requires that. And during runtime, if you want to write any temporary files, you can write it to the temp folder in your source code, because otherwise your file system is read only. So, and I already mentioned this, that there's a 4 MB limit to the payload size. So in general, I would advise you to mostly use the multi-step synchronous mode only. And you can also check your logs using the hub logs command. So there's also a command called hub logs, but also in your sorry, also in your deployment dashboard, you can actually see the logs. So you can go here and you will see your model being here. So I see the clip DSC model, right? I can go here and I can view the invocation history, what was the input and output to my models. And I can view the execution logs from the past 3 hours or whatever. So as you can see, all these models are here, all my model logs. So you can check those model logs as well from your deployment dashboard. So yeah. And if you have any questions, you can contact us. You can, I think, if you have direct, I think if there's a group, I think there's a WhatsApp group for you guys. So you can just put your queries on that. And yeah, also there's a support option here where you can also make a request if you want some other kind of support. So yeah, thank you everyone for attending this workshop. I hope you were able to deploy the model, and all the best for your hackathon on Tuesday.
So, ma'am, should we, or is it appropriate to create a WhatsApp group with the registered folks in the hack day?
Yes, Vivek sir. Actually, we have created one. So we can add you guys there, or how do you prefer?
Yeah. I mean, if it is okay with you, you can just add me and Bhavesh there.
Sure.
I'll share Bhavesh's number.
Yeah, please.
Yeah. So,
yeah.
Thanks, Bhavesh. Excellent session.
Absolutely, Bhavesh. Thank you so much. I'm sure, though some of the students, are slow in following, I'm sure the content that you have shared with them, the tutorial should help them, deploy a few more models so that they get a hang of it, and it will be helpful for the Tuesday session, for sure.
Yeah.
Thank you. So I guess that's about it for today. Any other comments, ma'am, or any students?
So once we add you in the group, students, you can, even ask your queries there. It's better that you start deploying these things, deploying few more models so that you'll be ready for Tuesday's session. It's better you start for Tuesday's hackathon right now, because 12 hours will not be sufficient for you to develop an end-to-end system. So some of you, I am sure, have started. I know some of the students have already started. Others who haven't, please get going with it.